Welcome to the office. Let's take a look a minute in section 2. We want to make sure we understand what we need to show that two lines are parallel, or if they're parallel, what that gives us. So let's take a look here. We're going to consider definition 2.16 is probably the place we're going to start, and then we're going to follow that with the property here. So definition 2.16. This is in reference to exercises, I think 4, 5, and 6 from this section here. So we have this idea of a diagram. There's two lines being crossed by a transversal, and then we have a definition for relationships between these angles as described here. Fantastic. What we really want to make sure that we know is how to use property 2.17. So L and M are parallel if and only if, here's the thing, you only need one of these three conditions to be satisfied. So really you could put or after these. So L is parallel to M in this figure if and only if alternate interior angles are congruent. So 4 and 5 are congruent. And that's all you would need. Or 3 and 6 are congruent. That could also be only what you need. Corresponding angles are congruent. All you have to do is show that one pair, 2 and 6, for example, are congruent, and then you would have parallel. Or interior angles on the same side are supplementary. So you could show that 3 and 5 are supplementary, and you're all set. You only have to show that one pair is actually congruent or one pair is supplementary as designated by these, right? These definitions for language give us what relationships are being described here. So you only have to show one of those things. So let's take a look at number 5 and number 6 are both homework problems. So let's take a look at number 4. So if L and M are parallel, redrawn here for convenience, then 1 and 7 are supplementary. 1 and 7. So what we have in our property is that the same side interior angles are supplementary. It doesn't give us that the same side exterior angles are supplementary. So that's a little bit interesting. All right, so what does this look like then? All right, how could we do that? Well, maybe let's do this in a few different steps. Since L is parallel to M, angle 3 and angle 5 are supplementary. We know that from property 2.7. So I could note that if I wanted to. Wouldn't be a bad idea. Then the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees. Fantastic. Maybe not that. Let's go also. Also, we could note that 1 and 5, angle 1 is congruent to angle 5, and angle 3 is congruent to angle 7, because they are corresponding angles. And again, that's given to us by property 2.17. Fantastic. Corresponding angles are congruent. Since since L and M are parallel, it gives us that those two things are congruent. Well, that tells us that the measure, right? So the measure of angle 3 can be replaced with the measure of angle 7. And the measure of angle 5 can be replaced with the measure of angle 1. And these are still equal to 180 degrees. That is, angle 7 and angle 1 are supplementary. And that's exactly what we wanted to show, right? We wanted to show that angle 1 and 7 are supplementary. So we're kind of working in the opposite direction in number 4 as compared to number 5 and 6 here. We're given that they're parallel, L and M, and then we're using that to draw some sort of a conclusion. But we would be able to do the same thing working in the other direction, actually, because of that if and only if situation with property 2.17. So if we were given, for example, that angle 7 and angle 1 were supplementary, then we would have that the measure of angle 7 and the measure of angle 1 is 180 degrees. Right? So I could follow this backwards. So if I know that they're supplementary, then I could say that their measures are 180. And now this is where it gets a little bit interesting. I can't use that this angle in that one and this angle in that one are congruent because despite being corresponding angles, they're only congruent if I know that L and M are parallel. What I actually have to use then is that angle 5 and 7 and that angle 1 and 3 are actually linear pairs. But that would give me that angle 5 plus angle 7, measure of angle 5 plus measure of angle 7 is 180, and measure of angle 1 plus measure of angle 3 is 180. And then I can do some substitutions. Then I could do some substitutions to this, right? So supplementary gives me an angle measure, linear pairs give me some new substitutions, and that would actually result in angle 3 and 5 being supplementary, which would give me that L is parallel to M. So I can go both ways here, maybe a little bit different justifications as we work through, right? Having to use the idea of a linear pair, and linear pairs are supplementary, but it gets us where we need to go. So again, number 4 worked correctly, as well as number 4 worked backwards there, described verbally. So if you have any questions, of course, make sure you reach out. Thank you for asking your questions, and I'll see you guys back here in the office in just a little while.